My name is Christopher Black. I am a solutions architect with CircleCI. I've been with the company for coming up on my 5-year anniversary. But my role at the company is to help teams build better software and ultimately increase confidence in the platform. Like I said, I've been at the company almost 5 years. Some might say that's a lifetime in this industry, but I absolutely love the company, love the tech, love the product, love the company. I spent the first couple of years here on the SRE team, so my background from a technology perspective is predominantly DevOps, infrastructure engineering. Quick run through of the agenda. We're going to spend a bit of time today talking a little bit about the company's history, who we are, a bit about continuous integration, the space we're in. Actually, we're going to do things a little bit differently. I'm going to save the product demo at the end. We're going to spend a lot of time talking about core features that are available in the platform right out of the box. And I think after we've established a little bit of context, who we are, some of the features that are available, how easy it is to get started, we'll establish a little bit of context for the platform demo at the end. I'm very much hoping to save a dedicated 10-15 minutes at the end for Q&A. So please, 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 any questions at all, save them at the end. I'm happy to dive in. All right, I love this slide. What is CircleCI and why should I care? Well, I'm going to assume that most of you are, all of you are familiar with continuous integration, familiar with continuous deployment, continuous delivery, DevOps, but a little bit about the history of continuous integration as it relates to our company's history. Continuous integration was very much a niche software practice that a lot of forward-thinking, sophisticated teams in various permutations were practicing many, many years ago. If any of you have read the landmark book, Kent Beck's Extreme Programming, written in 1999, fabulous read. What Kent Beck talked about in extreme programming was very much, you could think of it as a precursor to continuous integration. Kent Beck had this crazy idea. He says, well, if you're trying to ship better code quicker, more deterministically, maybe you should think about committing small iterative chunks into a mainline branch, right? So the practices that would ultimately be formalized into continuous integration, people have been talking about these things for years. But if we think about how complex software is today, if we think about just some of the changes that have happened in the industry, the proliferation of containerization, the digital transformation shifting left, baking application security into baking application security earlier on into the development lifecycle, all of that has kind of necessitated a practice like continuous integration at scale, in my humble opinion. We think about software 10, 15, 20 years ago, most software was custom, handcrafted, proprietary source code, with exception to modules and libraries, things like low-level networking. Most software applications were proprietary. But if you fast forward to the 2010s and beyond, software is not entirely proprietary, not like it once was. Now we're dealing with frameworks within frameworks, JavaScript frameworks within frameworks. Again, the proliferation of containerization technologies, Docker, infrastructure as code, all of the things that we collectively refer to as DevOps have fundamentally changed the way consumers build, test, and ultimately deploy software. And every industry is experiencing this change. And I also think it's worth pointing out that the distinction between a traditional company and a software company, that distinction doesn't quite exist anymore. And I think that's something many of you would attest to. Every company today is a software company, whether or not they realize it. Every company is affected by some capacity, generally a large capacity, by their propensity to interface with technology. Hello from CircleCI. So that's where a company like CircleCI comes in. We're a continuous integration platform first and foremost. You hear it in our title, or in the name of our company, CircleCI. And our mission as a continuous integration platform, first and foremost, is to make it as easy as possible to go from idea to delivery. And as I like to say, effectively narrowing the distance between idea and implementation, right? Here's a premise. Let's say somebody, product manager, somebody, doesn't matter, has an incredible idea for a product, for an application. Amazing idea, world-changing. How quickly and seamlessly can we bring that idea to life? That's where continuous integration comes in. That's where continuous deployment comes in. That's where DevOps comes in. And ultimately, that's where a company like Circle comes in. And we do this at a tremendous sense of scale. And I'm going to talk a little bit about the company's history, a little bit more about the engineering and our back end. But one thing to consider right off the bat is that we're running This slide's actually a little out of date. I think we're running now closer to 1 million builds a day. We're operating in 14 availability zones in AWS. At any given time, we have thousands of EC2 instances in our cluster. And it's safe to say CircleCI really was the first true cloud-native application, the first true cloud-native CI application developed. So we've been around for a long time. It's kind of crazy to think that we've been around since 2011. We're still very much a startup, but we've been around for a long time, and we're growing like heck. I have to constantly update this slide because the numbers are constantly changing, but currently we're at 320 employees. Like I said, I've been here for about 5 years. I think I was employee 31, but it's just been amazing to be part of such explosive growth, to work for such an amazing company with so many talented people. And again, we're a CI platform first and foremost. It's what we think about day in, day out. There are a lot of CI tools out there, most of them good, some of them great. A lot of them have an entire portfolio of tools associated with them, but our mission is continuous integration first and foremost. And down here at the bottom, this is just a handful. This is just a very small cross-section of some of the customers we deal with. We really do deal with entities of all shapes and sizes, from two dudes in a pizza.com to some of the world's most innovative technology companies. And this is a good visualization of where we sit in the tool chain. You can think of CircleCI, we're very comfortably in between source code over here on the left and a runtime environment over here on the right. That runtime environment can be anything from a Kubernetes cluster to a mobile device. And so if we have all, with all of that in mind, source code over here, the raw stuff that goes into building an application, and then the ultimate, the runtime environment, we sit comfortably at the orchestration layer. And to add a little bit more color to where we sit in the landscape, the entry point, generally speaking, for continuous integration is at the VCS. It generally starts with a commit. A developer commits code to GitHub or Bitbucket, we intercept a webhook, we kick off a build on our platform. And again, conceptualizing CircleCI and any good CI tool is very much at the forefront of your orchestration layer. At CircleCI, we're dealing with everything from, well, obviously building and testing code, but we have to consider things like the persistence of artifacts, notifications, Slack notifications. Every time you deploy something to Kubernetes, you get a nice custom Slack notification. Perhaps you're a mobile application developer, you're doing some serious mobile device testing. You might have to interface with some device farms, right, for true mobile application development emulation, right? So all of that together, we're comfortably at the orchestration layer. And then lastly, the crux of continuous integration is we're ultimately going to validate software. We're going to validate some code, and we're going to produce an artifact. And I use the term artifact very loosely. In my opinion, an artifact is anything that's left over after the build. It can be an executable, it could be a binary, it could be a Docker image, it could be an Android APK, doesn't matter. The crux of continuous integration is we produce an artifact. We have to then take that artifact and deploy it somewhere. So that's where the deployment side comes in. So with CircleCI, continuous integration, continuous deployment, we take this artifact, we ultimately have to propagate this artifact somewhere. Common examples, Kubernetes, ECS, the iTunes store, etc. Another nice visualization of different components on our platform. I can really geek out on this. This is a really cool visualization. I would not treat this as much as an architectural diagram. I would think of this more as a nice conceptualization of how the different components fit together on our platform. Now, of course, I cannot talk about a cloud-native CI tool without talking about security. It's safe to say security comes top of mind here at CircleCI. We are the most secure cloud-native CI application on the market. And I say this because we have a number of very prominent security certifications on our platform as well. How CircleCI protects your data, we could talk about this for hours. I have a following slide after this that talks a little bit more granularly about some of the features therein. But the long and the short of how we are able to implement security on our platform, as well as the deterministic nature of CI, it's something like this. Every time you run a build in an isolated environment, a freshly provisioned, isolated environment. That environment is isolated both at the network level and at the C group level. that environment has no knowledge of any other subsequent environments. That is a nice, cleanly isolated environment. We check out some source code. We execute whatever arbitrary commands are specified in your config file. We execute whatever makefile targets are in there. We run whatever scripts are in there. And then we ultimately destroy that environment. We destroy whatever artifacts are in there that aren't explicitly persisted. We destroy the source code, and then ultimately we tear down the environment itself. So not only does this lend itself to security, but this is also how we're able to implement nice deterministic CI on our platform, because it really does run in a clean, fresh environment each and every time. But a couple of things to consider when we talk about security. Another powerful feature I'm going to elaborate on a little bit further, and then we're also going to see it in the demo, is a very powerful feature called context. What the heck are context? Shared groupings of environment variables set at the administrative level, and then we leverage HashiCorp Vault under the hood to implement said contexts. And again, I really want to emphasize that each and every time you run a build on CircleCI, you really are running in a clean, fresh environment each and every time. No more, well, it worked on my local workstation. I'm not quite sure why it didn't compile on yours. Next couple of minutes, I'm going to talk about the core feature set. Once we've spent a little bit of time in the core feature set, I'm going to pivot to a platform demo. Demo should take about 10-15 minutes, depending on how quickly it takes to build some of these Docker images. And then from there, we're going to save a dedicated 10-15 minutes at the end for Q&A. First-class Docker support. What does this mean? It means that most of the time, folks are going to be running their build inside of a Docker image. And most of the time, at some point throughout the CI process, they're going to be producing a Docker image. We have a lot of really cool features that work right out of the box, such as advanced Docker layer caching. Things like that all lend itself to a very first-class Docker experience. Using something called the machine executor, I'll talk about that in a moment. You're able to do some pretty cool stuff with technologies like Docker Compose. Perhaps you're doing, you're testing multiple services simultaneously. Things like that all work right out of the box. Keep using that term, right out of the box, batteries included. Very important concept on our platform is this notion of workflows. Workflows, pipelines, the two terms can be used interchangeably, but the term of art on CircleCI is workflows. And a workflow effectively is an orchestration of jobs. Jobs and builds, those two terms can be somewhat used interchangeably, but on our platform, the term of art is a job. So with that in mind, a workflow is an orchestration of jobs. But I really like to talk about workflows. It's actually one of my favorite features to talk about, because in many other CI platforms, you have maybe a predefined set of stages. You have a predefined build, you have a predefined test, you have a predefined deploy, etc. On CircleCI, our workflows are effectively DAGs. They're directed acyclical graphs. So for those of you who remember graph theory and computer science, on CircleCI in your config file, you have total control over the shape of that graph. You have absolute control over the dependency graph. And what that means in practice, obviously, is the relationship between the different jobs in your workflow. So that kind of extensibility, that kind of customization right out of the box lends itself to developers being able to craft very, very, very powerful workflows that ultimately enable them to automate everything from commit to deploy. A fairly new feature that we've released are more advanced parameterization of our config. So we're continuously working towards decomposing our configuration DSL. We'll spend a bit of time talking about our config files. Very important concept on the platform. The TLDR is that all of our project config is written in YAML. All project configuration is stored in code. The steps that are executed in your CI process, if you're running your build inside of a Docker image, that's specified in your config file. The shape of your workflow, excuse me, that I just mentioned a moment ago, all of that is specified in your config file. But now the ability to further parameterize some of these keys in the config file just lends itself to more power, more extensibility. A very simplistic example of a parameterized config, how it can be used. Also, with our API, we've done some pretty significant work of late on our API to expand different build parameters in the pipeline. Good example would be you have a simple workflow, build, test, and deploy. You have a test job. You have a very, very large suite of tests. You have a build parameter, a very simple Boolean, run extra tests. If that Boolean parameter is present, run extra test equals true. You have an additional test suite you run under some condition. It's a very simplistic example, but I hope it hits home with regards to the value of a parameterized config. Resource classes, another very important concept on the platform. So we talked about workflows. A workflow is a collection of jobs. We have the ability to dynamically allocate different resource classes to different jobs in a workflow. And we'll get to see this in the demo towards the end of the presentation, but resource classes are effectively mappings of CPU and RAM to different jobs in a workflow. So for example, let's say I've got a workflow. Let's say I'm doing some mobile application development. I'm an Android developer, Android, Java, JVM, very computationally intensive. I'm probably going to want to run that on a large or an extra large resource class, just by virtue of that overhead because of the JVM. But the inverse, of course, is true. Let's say I'm doing I'm working with Terraform. I'm deploying some infrastructure. Well, Terraform under the hood is really just making a couple of API calls. Big fan of Terraform, very sophisticated piece of technology. But at the end of the day, it's really just making a couple of API calls to AWS. So if I wanted to be judicious with my credit consumption and I wanted to think about, okay, what's the optimal resource class usage for all these different jobs in the workflow, I would probably use less computationally intensive jobs. I'd run those on small resource classes. Deploy jobs, API calls. If I was doing any kind of static code analysis, I'd probably run that on a small box as well. For the computationally intensive jobs, for the Android jobs, if I've got a Rails application, for example, a very large Rails application, very prolific suite of tests, I'm probably going to run that on a large resource class. Jumped ahead here. Another very powerful feature, test splitting and parallelism. Parallelism and concurrency. Two terms very, very similar, but there is an important distinction to make between parallelism and concurrency. Concurrency refers to multiple jobs in a workflow running simultaneously. Parallelism explicitly refers to the parallel execution of a single job. I'm going to say that one more time. Parallelism on CircleCI denotes the parallel execution of a single job. And if we reason through that for a second, same job, parallel execution, what's the benefit of that? There's really no benefit of parallelization until you start to split your tests. And that's where we can benefit tremendously from heavy parallelization. So another very simplistic example, I'm a Python developer. I have 100 Python tests. If I had a parallelization of 10 for my build job, in theory, I could evenly distribute 10 tests to one node, 10 tests to another node, 10 tests to another node. Obviously, this is a very simplistic example. There's a lot more that goes into this, how the individual tests are written, where the test classes are located, et cetera. But I use that paradigm to illustrate a simple point, is that if we can evenly, I'm putting this in quotes, if we can evenly distribute tests across various nodes in a cluster, we could probably cut down on build time by doing that. And so test splitting and parallelization in apposition to writing good tests, writing clean, isolated tests, having a nice conscious system of how we're going to organize our test cases, et cetera, we can dramatically cut down on the time it takes to build our application on CircleCI. And so when I think about things like first-class Docker support, Docker layer caching, test splitting, and parallelization, as a developer, that gives me a very, very powerful toolbox to build better software quicker, more reliably, and ultimately cut down dramatically on my build times in CI. Orbs. What's an orb? You can think of orbs as a package manager for CircleCI configuration. So historically, every project on the platform had to have its own configuration file. And as you can imagine, if you're onboarding many dozens, hundreds of repositories, the notion of writing a config file for every one of those projects it's not super scalable. Moreover, I'm sure all of us can infer that many of those repositories probably share common libraries, common steps, common actions, common pieces of the workflow they might have in common. And so with orbs, one of the coolest features I think we've launched at CircleCI, it's enabled us to templatize and package bits and pieces of CircleCI configuration and share that configuration across however many projects in our org. And this is a nice visualization of what an orb looks like. Again, think of it as just templatized CircleCI configuration. What we can templatize, though, are the individual commands that are executed when you run a build, the executors themselves. I don't know if I introduced the concept of executors. An executor is where we run your build. It's basically the underlying environment where we check out your code and we execute the steps specified in your config file. So we can templatize commands, we can templatize executors, and we can templatize job definitions, job declarations, themselves. And remember, build, job, the two terms are somewhat interchangeable, but a job does represent the most atomic unit of work on our platform. One other thing I wanted to elaborate on before I move on from orbs. What's great about orbs, aside from just the inherent benefits of being able to templatize and package bits and pieces of CircleCI configuration, is this has opened up our platform for an entire ecosystem of third-party tools and services that have been built on top of our platform in the form of orbs. So CircleCI is not a plugin based architecture. And when oftentimes folks ask, well, if CircleCI isn't a plugin based architecture, how do I integrate with something like Slack or AWS or Kubernetes, for example? You would do so in the form of an orb. Highly encourage all of you to check out our orb registry. We have an amazing ecosystem of really powerful third-party tools, services, a lot of really cool things all of you should be considering doing as part of your CI process, everything from Aqua security scanning, static code analysis, etc. As you can see, I'm a big fan of orbs. Orbs are a very powerful feature, and I'm sure all of us, just as technologists, recognize the intrinsic benefits of templatized configuration. Matrix config, matrix jobs, matrix builds. Very powerful feature. Matrix jobs, basically, if you're trying to test multiple versions of, say, Node, you're testing multiple versions of Node against multiple versions of Chrome, for example. We have very, very slick configuration syntax where you can create, basically when you use matrix jobs, you can think of it as a multi-dimensional array, but what you're doing is you're creating a Cartesian product. And when you run a matrix build and you get that nice visualization of the different matrices, it's a very powerful combination to just build different tools quicker, more effectively. We talked a little bit about context when we were on the security piece, but I'm just going to elaborate on it a little bit more. When we talk about secrets management on the platform, we generally refer to a really powerful feature called contexts. And we leverage HashiCorp Vault under the hood to implement our context. HashiCorp Vault is an industry-leading KMS technology, exceptionally well-written software. So you can think of contexts as an abstraction layer, our own proprietary abstraction layer on top of HashiCorp Vault. And again, these contexts are set at the administrative level. These contexts are then exposed or mounted to individual jobs in a workflow. So let's go back to that example, very simple example, build, test, and deploy. I have a deploy job. I'm deploying an artifact somewhere. Let's say AWS, let's say a managed Kubernetes cluster. Well, at bare minimum, I'm going to need some AWS credentials to authenticate, to ultimately, facilitate that deployment. I have these AWS credentials stored in a context. I'm going to call that context. Doesn't matter what I'm going to call that context. I am only going to expose that context to my deploy job, right? Because there's no reason for the build and the test job to have that context, to have those secrets present in the execution environment. And if you think about that from the perspective of security, security through obscurity, et cetera, those secret values aren't even present in the build environment. They're not even present in the test environment. Those secrets are only present in the deploy job. In that job, remember, that job environment is destroyed at the terminus of that job. Very powerful stuff. We also have a couple other features to set up project-specific environment variables, project-specific secrets. I generally recommend folks look at context. It's just a very powerful feature. And I think the granular benefits of being able to set it at the org level are pretty powerful. A question I get asked all the time working for CircleCI is, how do I deploy to Kubernetes? Can I deploy to Kubernetes? What does the Kubernetes deployment look like? we have a couple of very powerful orbs, all centered around different Kubernetes technologies. We have an EKS orb, an AKS orb, a GKS orb. The long and the short of it is, as long as you have your Kubernetes credentials, whatever they are, probably a couple of certs, a URI pointing to a cluster, etc., with the proper orb, you can quickly and seamlessly deploy to Kubernetes, manage Kubernetes, Kubernetes running on bare metal, etc. We have very strong mobile application support on our platform. Most of our infrastructure runs on AWS. A very small percentage of our infrastructure runs on GCP. An even smaller subset of that infrastructure, we have physical Mac hardware. So we have a data center in Milwaukee with 50 or 60 racked Mac Pros. And as many of you know, in order to do true mobile application development, iOS mobile application development, you have to do all of your compilation on physical Apple hardware. So by us maintaining that rack of physical Mac Pros, that's how we're able to facilitate iOS application development. And on the Android side of things, it's pretty straightforward in Linux. Highly encourage all of you to take a look at some of our tutorials and our example projects. If nothing else, most of the configuration files in all of these sample projects represent best practices and were written by a lot of our internal engineers. So if any of you see languages or frameworks here that you're interested in, you're curious, you just want to get started, highly encourage all of you to take a look at the example projects. And more importantly, just spend a couple of minutes on the config file just to get an idea of how you would build that project using best practices on the platform. All right, platform demo. Been talking a lot, let's shift gears here to a platform demo. Awesome. All right, just had to switch gears there for a minute. Let's talk a little bit about what we're going to run through over the next 10-15 minutes. We have a simple scenario where we're going to build, test, and ultimately deploy a Node.js application to Heroku. Sometimes I use Kubernetes, sometimes I use ECS, but I think just for the sake of brevity, we have a single containerized application. We're just going to deploy that to Heroku, less moving pieces. I generally start a platform demo kind of in media res with a pull request I have in flight, and I start here for a couple of reasons. I start here because our integration at the VCS level is very, very strong. Adding a project on CircleCI, it really is just a matter of clicking add project in the UI, and then you're good to go. No masters to set up, no underlying build infrastructure to manage, no webhooks to configure. It works right out of the box, batteries included. So that's one reason why I generally start with the pull request. And then the second reason I start the demo and media res with the pull request is because this is generally the entry point on the platform for most developers, is with a pull request. So I've got this pull request. I'm trying to I'm trying to push a very small change to this Node.js application. And very clearly within the pull request, I see that my tests have failed on Circle. Uh-oh, let's find out why. Awesome. I assume hopefully most of you are CircleCI users, have used the platform in some capacity. I am going to just assume this is everybody's first time seeing a jobs page, just in the interest of brevity. There's a lot going on here. First thing I want to point out, adding a new project, it really is just a matter of clicking add project. I don't have any webhooks to configure after that. I don't have any underlying build machines to set up. I click add project, I write my configuration file, boom, good to go. Everything we see here, these are all steps that I specified in my configuration file, restore cache, fetch dependencies, etc. But what I'm interested in as a developer is my failing test. And we have a very handy feature where the test failure is clearly indicated at the top of the UI. So rather than having to scroll down and look at copious amounts of build output, I can see my test failure very clearly indicated at the top of here. And so what we see is a very, very simple assertion statement that failed. But as a developer, armed with this newfound knowledge, now that I have a better idea of why my test failed, I'm going to go back to my code and I'm going to update my failing test. I'm going to switch directly to the feature branch itself. And if it looks like I'm using GitHub's online text editor to modify production code, I am. And I'm only doing this because this is a demo, and I have an old ops manager who'd probably have my head if he saw me doing this in a production, you know, in the real world, but I think for demo purposes, we'll be all right. And so I'm going to find this failing test, do failing test. Awesome. You're going to commit this change directly into the feature branch. I'm going to go back to the pull request. And here we see that now, because I committed that wafer thin change, CircleCI intercepted a webhook. We kicked off another build. Things are starting to get a little bit more interesting. And we can see very clearly within the pull request that I have a build that's currently running on Circle. And everything we see here, it's all happening in real time. We're spinning up a Dockerized environment. We're pulling in some dependencies. I'm checking out source code. Ultimately, I'm going to execute whatever arbitrary commands are specified in the config file. And then ultimately, I'm going to report a status back to GitHub. Generally on our platform, it is a very binary status. Your build passed, exciting, great, or your build didn't pass, your build failed. Uh-oh, we got to find out why. In the event that you don't have a pass or a fail, every now and again, we have something called an infrastructure failure, and that's if something on AWS or GitHub or any of our upstream providers would be causing a non-deterministic build failure on our platform. It happens very, very, very seldomly, but when you're running CI, it is a very binary. Your build passed, great, or your build didn't pass. We should probably find out why. I am running a fresh NPM install here. I do want to point out we have pretty advanced caching features that work right out of the box. Generally a cache though on our platform, it's a mapping of a key to a hierarchy of files. We'll talk a little bit more about that in a second. While that build though is running, I just thought I'd give everybody a nice visualization of what a workflow looks like. And this is what I mean when I say the visual representation of the different jobs, the relationship between the different jobs. So these lines here all indicate a relationship between these different jobs. And to the astute observer, you will notice that code linting, build Docker, I'm going to build a Docker image whether or not my code linting job passed. Code linting, static code analysis is very important, but I have the ability to say that build Docker image, this job only depends on these two jobs down here. Let's see what's going on over here. Gonna give this a refresh. Whoa. Well, that happened really fast. It's a pretty straightforward Node.js application that we're building right now. It might come as a shock that I've over-engineered the heck out of it, but wow, that build took like 2 minutes. Every one of these status notifications within the PR corresponds to an individual job in the workflow. But I just want to go back, trust but verify. Rerun from failed. So I have this job over here, run integration tests. This is on the master branch. Instead of rerunning this workflow from the beginning, I'm just going to rerun that from the failed job over here. Awesome. But the good news is it looks like our application code within the feature branch over here, all of our tests have passed over here. And this is good because as a developer, now that I am confident in the quality of my application code, all of my tests on the feature branch have passed. The integration test on the master branch, I do think I have a flaky test in there. But on the feature branch, all of our tests have passed. I'm a developer. I'm confident now in the quality of our application code. I think I'm going to merge this into the master branch. Awesome. So by merging that merging that PR, by merging that feature branch into the master branch, that's going to trigger another workflow on the platform. You all should notice that the shape of this workflow is slightly different than the last one I had up a moment ago. And the reason is because I have powerful branch level filtering within my workflow stanza. And I'm gonna show you all what that looks like in just a moment. What I want everybody to conceptualize though is that all of my deployment logic, I encapsulated my deployment logic in a deploy script. And that deploy script is ultimately gonna use the Heroku CLI to make a couple of API calls to Heroku so we can deploy the image that we're building to a Heroku dyno. But I've encapsulated all of that deployment logic in a job called deploy application. That job will not run unless it's on the master branch. And in an example like this, that makes sense, right? We're only going to deploy our application. We're only going to update our application on a successful push to the master branch. Another thing here, another indicator that the shape of this workflow is slightly different than the last is this right here, the approval piece. As many of you know, even in organizations with sophisticated automation, mature DevOps practices in place, people like and sometimes need the comfort and the control of a manual approval step. And there are some industries, just by virtue of regulatory compliance, that there are very stringent laws that say every time somebody makes a change to an application, one or more people have to explicitly approve that change. So we have that functionality at CircleCI. It works right out of the box. Might come as a shock if I said you configure it in your config file, but unless myself or somebody else with explicit access to this project actually approves the deployment, we're not going to update our application in Heroku. My integration tests, my flaky tests. Rerun from failed. Very powerful feature rather than starting that workflow at the beginning. So in my browser test and in my integration test, I do have a couple of flaky tests in here. I think that this execution should hopefully eliminate some of that. While these jobs are running, let's take a peek at our configuration DSL. So CircleCI configuration, it's written in YAML, but you'll find that what a lot of people do to cut down on the verbosity of their configuration is they encapsulate a lot of logic into shell scripts, they'll execute makefile targets, they'll leverage some of the cool build parameters I talked about a few moments ago, and they'll also leverage orbs. And then I guess a final piece there, if you're really trying to take your configuration, your YAML foo to the next level, anchors and aliases. All of this is pretty straightforward. I like to give all of my jobs in the workflow nice, meaningful names, build node application, run integration tests, etc. Where things get very interesting, I'm actually going to start here on line 167 on the workflow stanza. So starting on line 57 with the keyword workflows all the way down to 214. And this is how we mount that context, that shared grouping of secrets that I need to deploy this application. That's what that looks like down here. But this is what a workflow stanza looks like. If you've ever seen YAML in any capacity, you're familiar with what this looks like. It's not exactly rocket science, but there is a bit going on here. What's important to realize, though, is that within this stanza down here, this is where we're defining that relationship between the different jobs in our workflow. And more importantly, this is where we're able to leverage that branch level filtering. We also have very powerful tag level filtering, but this right here is very straightforward. This deploy application job is only going to run on a successful push to the master branch, and that job is also going to mount a couple of secrets that we need to deploy our app to Heroku. Awesome. All right. The moment of truth. So all of our jobs down here have run successfully. We're getting ready to deploy our application to Heroku. Approve deployment. Let's do it. It's great that we see the profile associated with the VCS entity that approved the deployment. So that's That's my photo on GitHub, 8effects. That's my hacker name in Latin. There's a story behind that. Just run with it. I want to point out our deploy job here. This is the final job in our workflow, and this is kind of the meat and potatoes of the show, if you will. This job is where we take this Docker image that we produced earlier in our workflow. We're ultimately going to deploy this Docker image to Heroku. It's a lot going on in the UI, but a couple of things I want to unpack right off the bat. Resources. Remember earlier we talked a little bit about this notion of resource classes in our platform, the ability to dynamically allocate different resource classes to individual jobs in the workflow. What do we notice about this resource class here? A single CPU and 2 gigs of RAM. This is a small resource class. And I'm running this in a small resource class for 2 reasons. One, we have usage-based pricing on our platform. Think of it like AWS On Demand. You pay for the resources you use as you use them. We also have a very generous free tier. But in the spirit of being smart and judicious with my credit consumption, I'm going to run the simple job the simple deploy job on a small box. And I'd encourage all of you to think about, to think judiciously when we're putting together our workflows about the optimal resource class usage. Use big, large boxes when applicable, but again, the inverse is also true. Run your build on a small box when opportunity allows. And so I've got a custom Slack notification over here. This pipeline run was successful. Boom, boom, boom. So in a few short minutes, we were able to build, test, and deploy an application end-to-end using a lot of really powerful features that are available out of the box. Say it one more time, batteries included, no plugins. And just so you all know, I did not do a sleight of hand. I exposed a lot of meta build information in the form of this endpoint here. CircleCI exposes a lot of this meta build information in the form of environment variables that are present in your CI environment. So generally what I do is I take some of this meta information and I use it to tag images, I use it to tag assets that I deploy into production, etc. But with all of this meta build information here, this gives me that end-to-end traceability. So every time I have an asset in production, I can tell you when that asset was deployed, who deployed it, and I can ultimately take each and every asset in my cluster, in my ecosystem, and I can trace it back to the individual commit or to the Jira ticket that instantiated that. That about wraps it up for the platform demo and for the presentation at large. I know we've got 17 minutes left, so I'm very, very happy to answer all of your questions. All right, lots of questions here. I'm just going to start at the top. So we have a question from Cyan. Please recommend the best book to learn DevOps. I'm going to answer this live. The best book, hope you're all listening, the best book to learn DevOps, there are 2. The DevOps Handbook. I highly, highly recommend all of you read the DevOps Handbook. It's absolutely great. One of the authors who wrote the DevOps Handbook wrote a pioneering book called Continuous Delivery in 2007. Continuous Delivery is a landmark work that more or less codified and articulated the notion of a CI pipeline. Again, remember at the onset of the presentation, people have been doing CI for many, many years. It wasn't until 2007, Continuous Delivery, where a group of, well, frankly, luminaries in the industry said, okay, folks, if you want to build good software, this is how. And so they articulated the concept of a delivery pipeline, good continuous integration practices, et cetera. Short answer, short question, long answer, DevOps Handbook, Continuous Delivery. Malesh Kumar asks, can we pass output of one orb as input to another? Output of one orb to input is another? Yes. Yes. Short answer is yes. Malesh asks, another question, matrix config, can we pass other parameters other than OS? Yes, absolutely. Cyan asks, would CircleCI be adding support for Flutter in the future? I'm not sure what Flutter is, full disclosure, but Generally, when people ask me if something works on the platform, if Flutter has an API, if it's a command line tool, if it's something that we can install in our build environment, if it's something that I could run inside of a Docker image, then it runs on Circle. If it runs in Docker, then it runs on Circle. If it has an API, then we can connect to it from Circle. Enrique asked a question, great question. Why is that process so long? So I over-engineered the heck out of this Node application for demo purposes. I have a pretty exhaustive suite of tests. One of those tests I need to refactor. To be honest, there are like 2 or 3 tests in my integration test suite that, yeah, I just need to refactor those and write some better code. How can I speed up the cache restoring and the whole process? Wow, excellent question. I will try to do it justice. Firstly, I would recommend all of you take a good look at our caching documentation. They put forth some pretty good high-level strategies on just general caching strategies on the platform. When I think about caching and just speeding up the build process in general on Circle, there are a couple of things that immediately come to mind. Tabling dependency caching for a second, the first thing I want to do is consider running my build inside of a custom Docker image. I want to consider building a custom Docker image with only the things that I need for my build environment, whatever tools, languages, frameworks, nothing more, nothing less. And the degree to which I can cache dependencies or other, I'm just going to say assets in that custom Docker image can dramatically speed up my build process on Circle. We maintain a number of what we call convenience images, and our convenience images are just popular off-the-shelf images that we put a couple of tools inside of the AWS CLI, et cetera, we maintain for customers. And our convenience images are great. I think for a lot of folks who are just getting started, it's really great to just take one of our conveniences off the shelf. When we start to think about more sophisticated use cases on our platform, production use cases, it starts to make sense to think about a custom Docker image. So having a custom Docker image, some good caching strategies, Docker layer caching, writing a good Docker file, parallelization and test splitting, all of those things kind of come to mind when I think about what can I do to shave off a few minutes from my build. I hope that helps, Enrique. And again, I definitely encourage you to take a look at some of our caching documentation. They have a couple of really good high-level strategies. And I guess a final point there, it also very much depends on the language that you're using. I'm going to make a joke here for anybody who's written any Node, pulling in Node modules. You're basically pulling in a neutron star at that point. Anyway. Will the link to the recording and slides be email? Yes, absolutely. And I think we're going to put this on YouTube for posterity. And at some point, I've got this as an action item on my end. All of the demo assets, if you see myself or another customer-facing engineer at Circle run through any kind of platform demo or technical demonstration, what we're trying to do is put all of those assets on a public-facing repository, very similar to our examples and getting started projects. Is there a possibility to dynamically choose resource type, CPU, medium, large? I'd like to know a little bit more about dynamic. But if you're looking for a kind of mechanism where you can conditionally say, under these conditions, use a medium box, and under these conditions, use a large box, no, not seamlessly. Not seamlessly. It would probably require a lot of custom bash scripting. I come from an ops background, so I love putting everything in shell scripts, but it would be a very gnarly shell script, and you'd be making a lot of disparate, disjointed API calls. At some point in the future, I have no doubt it's something on our product team's roadmap to be able to take signals, some kind of conditional, and say, okay, under these conditions, run this job on this resource class. Under these conditions, run it on a different resource class. We're not quite there yet. Miriam asked, is it recommended to set up integration tests through CircleCI? Yes, absolutely, absolutely. Any kind of software testing that you do locally, I highly recommend doing so on the platform just because of the deterministic nature of CI. And when you're using a cloud-native CI tool like ours, no more it worked on my workstation locally, not quite sure why it didn't compile on yours. So I highly recommend integration test, functional test, any kind of testing that you can achieve on the platform. I generally recommend doing so. Oh, excellent question, Keith. So Keith asks, can you suggest debugging approaches to using CircleCI itself, like when a workflow or job you've expected to run can't be found or fails in an unexpected way? 100%, 100%. And I omitted this in the course of the presentation because it's a feature sometimes we take for granted, like good plumbing, but we have the ability to SSH into a built environment on Circle. We have a really handy, so that's the first thing I would do. Invariably, if I'm debugging anything on the platform, first thing I'm going to do is I'm going to SSH into my build environment. I'm going to start poking around, I'm going to start looking at log files, and I'm going to start to do a deeper investigation. So in the jobs, in the UI, on the jobs page, we have a button. In fact, I'm just going to share my screen and show everybody. I'm just going to demo this live. So up here, you click rerun job with SSH. This is a very, very powerful feature. This is going to rerun the job, same commit, same execution environment, same code. This was not really part of the demo. We're just kind of doing this live right now, but this is a really cool feature, and I'm really excited to share this with all of you. So when I click rerun with SSH, it's going to rerun the same job, same code, same commit, except this time it has an additional step where it furnishes an IP address and a port. Now make no mistake, I've spent quite a bit of time with a nice SSH config file. I've I've already associated the appropriate SSH credentials and everything on the platform. So that's what I'm using to authenticate here. And it happens very slick, it's very seamless, it's under the hood, but I just want to be very clear, this is not an unauthenticated SSH connection at all. And again, I've already got my SSH config file set up. So I'm just gonna hope all of you can see this okay. So the first thing I would do in debugging a build on CircleCI, I'd SSH into the build, I'd start looking at log files. I also encourage everybody to persist test results, persist any kind of artifacts, persist any kind of artifacts that are indicative of your CI process. And then at the end of a build that might have failed non-deterministically, a build, a functional test timed out, I would look at those artifacts and assets, and then I would just continue to debug from there. And if worst case scenario, I always encourage all of you to reach out to our support staff. We have a really awesome support team who would be more than happy to help you debug a build. Question from Kevin. Do you have any clients using CircleCI with Adobe products like AEC CMS? Done because we're being told to evaluate as their own enclosed ecosystem. So, okay. So the question is about using two Adobe products, AEC and CMS on CircleCI. Unfortunately, and not a dumb question at all, Kevin, thanks for asking. Unfortunately, I am not as familiar with those two Adobe products. Again, if either of those products have any kind of command line tooling or any kind of API available, I guess I'd have to know a little bit more about how those tools work. Presumably they could work on CircleCI. I always tell everybody though, if it runs in Docker, it runs on Circle. We have a couple of minutes left. Any final questions, comments, anything at all, happy to help. My absolute pleasure, Kevin. Heather asks, what is the difference between a pipeline and a job? The new interface has pipelines and yours has jobs. Heather, another wonderful question. I'm still using the old UI. We've made some pretty significant investments to the UI of late. I've just spent a lot of time with my demo applications. I spent a lot of time setting all of that up in the new UI. At some point soon, I need to just bite the bullet and port all of those settings over to the new UI. But to answer your question a little bit more succinctly, a pipeline contains jobs. Pipeline and workflow, those two terms are very much interchangeable, and a workflow is an orchestration of jobs. Hope that answers your question. Ooh, Enrique, any thoughts on rollback strategies? I generally encourage folks to roll forward. There are reasons why I have a deep-seated philosophical belief, in rolling back. We should really be thinking about rolling forward, but tabling that, you would roll back on our platform by effectively rerunning a workflow with the state, with the commit associated with the last known good state. And what I would do if I was using CircleCI for continuous deployment, and I was deploying multiple containerized services to like a Kubernetes cluster, I had all of this automated, and I was using CircleCI, I would probably invest a little time in a dedicated rollback or roll forward job. I'd have a very specific isolated job with the appropriate parameters, the appropriate, let's just say you're using Kubernetes, the appropriate Helm files, et cetera. I would have a dedicated job that I would execute in the event of an outage or something. Hope that helps. Keith asks, what about when a workflow isn't there when like a cron job that for whatever reason didn't get run? Okay, so Keith, in that scenario, I highly encourage you to reach out to support@circleci.com. We have an amazing support team. Most of them are engineers who are very active in the community. But for a cron job, for a mysterious cron job that should have ran, didn't run, highly encourage you to reach out to support@circleci.com. I would say we call them scheduled workflows. You have cron POSIX syntax in the config file. I would sanity check your cron syntax is valid, because cron syntax can be kind of painful at times. So I would just triple check that your syntax is correct in your config file. My absolute pleasure, Enrique. We've got 3 minutes left. Any final questions at all? Going once? Going twice? Awesome. Well, everybody, I hope all of you found this valuable. We definitely covered a lot today. I want to thank you all so very much for your time, and hope to see you again next time.